Have you ever tried finding the slope of the line tangent to the function but didn't know how or what to use? Have you ever felt hopeless when you couldn't find the velocity, acceleration, or jerk from a position function? Well, look no further.
Hi, I'm Derivative Dan, and I'm here to talk to you about derivatives.
Dan, what's a derivative?
The derivative is the slope of the line tangent to the function.
But Dan, not to be rude, but why should I care about derivatives?
Well, Tangent Tina, math is a universal language and can be used around the globe. Also, derivatives are used in physics when looking for velocity, acceleration, and jerk. The real reason I'm here today is to talk to you about derivatives. Alright, so we're going to start off real simple. Derivative of a constant function. Although this may be simple, this is a derivative you're going to see in your every day-to-day life. And if you don't have this implemented in your mind because you purchased this from me, Derivative Dan, you're going to be screwed. The derivative of a constant function is always 0. A constant function is just a number. So like if f of x equals 5 is just a flat line. So its derivative, or the line tangent to the slope, is 0. Here we have the constant multiple rule. Whenever there's a function like f of x equals 7x with a coefficient in front of a variable, the derivative of that function is simply the leading coefficient. So that becomes 7. Over here you could purchase the power rule for positive integer powers of x, more commonly known as the power rule. Anytime you have a function like f of x equals 3x squared, you take the exponent and multiply it by the leading coefficient, and then subtract 1 from the exponent. So the derivative of 3x squared would just be 6x to the first, or 6x. Oh hey, over to my right, we have the power rule for negative integer powers of x. Similar to the power rule for positive integers, whenever there is a function with a negative exponent, you multiply that exponent by the leading coefficient and then subtract 1 from the exponent. So a function like f of x equals 3x to the negative 3, the derivative of that would be negative 9x to the negative 4. A key derivative to your collection is the sum and difference rule. This is basically the power rule applied to functions with addition or subtraction. So the function f of x equals x plus x squared becomes 1 plus 2x. This is the quotient rule, which is one of the more complex rules for differentiating functions. This function, f of x equals 2 over x plus 1, has both a numerator, 2, and a denominator, x plus 1. When differentiating this function, you'll take the denominator of the original and square it, which will become the denominator of the derived function. Then, for the numerator, which is a bit more complicated, you will take the denominator, x plus 1, and multiply it by the derivative of the numerator, which is 0. Then, you will subtract the numerator, 2, times the derivative of the denominator, which is 1, for your whole derivative. This is a product rule. You use the product rule when you have one function that consists of two differentiable terms being multiplied together. To find the derivative, you take the first term and multiply it by the derivative of the second term. So 4x to the third multiplied by the derivative of 3x would be 3. Then you add that to the second term multiplied by the derivative of the first term. So 3x times the derivative of 4x cubed would be 12x squared. This is a chain rule, the final and most complex rule for differentiating functions. When you have a function within a function, such as f of x equals 3x plus 1 all squared, you use the chain rule to find its derivative. When differentiating this function, you will take the derivative of the outside, so bring the 2 down, multiply it by the baby, keep the baby, which is the inside, the same, subtract 1, so you have 2 times the quantity of 3x plus 1, and then you multiply that by the derivative of the baby, which would be 3. Then, to make it all simple, you will combine like terms to get a final derivative of 6 times the quantity of 3x plus 1. This can be used to 3, 4, or an infinite amount of times if they're the function within a 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 function.
But wait, there's more! If you call the number on your screen in the next 20 minutes, you could receive a limited edition handy dandy tool to remember key functions and their derivatives. Here's a sneak preview of all that is to come if you purchase from Dan's Derivative Store. I have my red marker here. Pretty sexy. You know what else is sexy? Tomatoes. Super sexy tomatoes. So the way this acronym works is you write the function that is correlated with the letter. So S, secant. S, secant. T, tangent. On the next row, you write the reciprocal functions of all these. So cosecant, cosecant, cotangent, and this cosecant has a negative sign. From here on out, it's pretty elementary. If you want to take the derivative of any of these functions, you merely take the product of the other two. So the derivative of secant is secant times tangent. The derivative of cotangent is negative cosecant squared. If you call the number on your screen right now, you can receive all of this and more for only 5 payments of $19.99. I'm Derivative Dan. Differentiate your day today. 40. Let's get this third down, boys.
72. Set. Oh, hi.
Oh. Be a stud wide receiver. Derivatize your day today.